So far, we thought about matching people with options and allowed people to tell which option is acceptable and which one is not acceptable. Next, we want to allow them to express their preferences in a more subtle kind of way. We want to allow students to say how much they like the room. They can have higher values that will express that they like it better, that's their favorite room, and the lower value is less good or maybe barely acceptable. We're going to think of this preference values as money that person is willing to pay for the assignment. These preferences will give us trade-offs. We can give one person his top choice, and as a result, someone else needs to get something he or she likes less. So let's think about this in the context of an example. So the example has three people, Shin, Yoram, and Zach, and they have three items for sale, item A, B, or C, and the table here expresses values for each of these three items. So, for example, Shin's value for item A is 10, and her value for B is 7, her value for C is only 4. The first thing we're going to think about is marking everyone's favorite item. So Shin's favorite item is 10. We're going to set up a preferred seller graph, a graph in which the nodes are the buyers and the items, and we connect each person to his or her favorite item. So Shin will get connected to item A. Similarly, Yoram's favorite item is also A, and Zach's favorite item is B. So we're going to connect Yoram to A and Zach to B, and we call this the preferred seller graph. Now, this doesn't actually give us a solution because, as in the example, A is over-demanded. Both Shin and Yoram would like to have A as their favorite item. So now we're going to have to think about trade-offs of how we're trading different options off. So let's think about how to evaluate an assignment or a way to match people with item. So one possible assignment is to assign Shin to A, Yoram to B, and Zach to C. This, we can add up the values these people have for the assignment and have that this assignment has a total value of 10 plus 7 plus 5 for a total of 22. In fact, very simply, we can do better. We can have Yoram and Zach swap the item, and this way we'll get a total value of 25, 10 plus 9 for Zach's value for B, and 6 for Yoram's value for C. That's better than 22 we had before, and in fact, this is as high as it can get. This is the maximum. There's one issue with this high-valued assignment or high-valued matching we created. We're going to have to convince our buyers to accept the choices. In the example, it's easy to convince Shin and Zach, who got their favorite items each, but Yoram is a bit more problematic because he didn't get what he really wanted. There's an important aspect of how people get convinced to change preferences that we haven't thought about yet, and those would be prices. So when we add prices, then let's think about what effect they have. In the example here, I simply added a price for each of my three items. So maybe A and B have price 2 and C has price 0. These prices modify players' preferences. So Shin, who used to have a value 10 for item A, now has to pay 2 to get the item. So her remaining value, which we're going to call net value, is 10 minus 2. That's only 8. Similarly, we can compute net values for all of Yoram and Zach for all of the items. And the net values decrease every value by the price. So, for example, Zach's value for item B is now 7 instead of 9, again, taking away the price 2 for item B. And given these net values, I can again draw the preferred seller graph, connecting every player with the favorite item, but this time a favorite item is the one with maximum net value, taking the prices into account. What's really nice about this particular set of prices that we started with, that we can have everyone get one of the favorite items they got. If I let Yoram have item C, Shin A, and Zach B, then what we say that the market clears, we can assign everyone to their favorite item. So what we see that market clearing prices have a way to resolve contention. It allows us via the prices to modify people's preferences, and when the market clears, when there is a way to assign everyone a favorite item, then prices worked beautifully in resolving contention, and everyone got what they most wanted to have. But going back to what we thought about in the beginning, how does this relate to maximizing total value? Is there a trade-off between wanting to have as high total or sum of values as possible and resolving contention, or is resolving contention actually also does well in maximizing total value? This is what we're going to think about next.